2, which is about the modeling of the 20-story proposed building. And the module 2 contains the modeling of the proposed 20-story building using 3 methods. The first one is the direct import of the grid lines and columns from the CAD file, and we will be using this. But I will briefly discuss these 2 methods. The second method is using the quick draw template of the ETAB, and the third method is using the grid lines in ETAB. So before we start the modeling of the building, so let us discuss the architecture drawings which we will be following. This is actually not a proper architecture drawing, but I have made it for the design of this course. It consists of one basement, which is normally used for the parking. So we have basement one basement which is used for the parking, and then we have ground floor to fifth floor, a typical floor for the use of offices, and we have a grid of 25 feet in the x direction and 20 feet in the y direction. Uh, I have selected these grids because these grids are normally used in Pakistan. Sometimes you will find out the grid 25 plus 25, or sometimes it will be 25 plus 20 feet. So after that, we have sixth floor, in which we have a restaurant, and this is the opening starting from the sixth floor. And the next one is the seventh to 10th floor. Again, actually, these are again the offices, which will be used in offices, or you can use it as a apartments. This is actually apartments, not offices. Because we have used the offices in the lower stories. So from the 7th to 10th floor, we have apartments, and again from the 11th to 18th floor, again we have apartments. But the difference is in the grids. You can see that grid 2 is not available in 11th to 18th floor because the building is becoming slender when you go up. And at the roof, we have a Monty and or Heva tank, and this is again Monty. So we have two lifts, which is actually when you get the drawings, the lift will be proposed by the architect. But when you are designing your structure as a dual system, then you have must propose shear walls, and you must locate those shear walls, and you send back that file, AutoCAD file or Revit file, to the architect that we are going to provide these shear walls, so adjust your architecture drawings according to these shear walls. But if you don't, for example, if you send these locations to the architect and he do not approve that, then you have to find out alternate solution, which is the find another locations for your shear wall, which can contribute in that structural system, which will be classified as a dual system, right? So the first basement plane, we have 10 grids in the y direction and 8 grids in the x direction. And when we go up to the ground floor to fifth floor, so these two on the grid 10 and grid 1 is not included in the ground to fifth floor. Similarly, grid A and H is not available in the ground floor. It means it has been slandered in the ground floor to fifth floor. So it is similar to up to the 10th floor, but in the 11th to 18th floor, again, grid number 2 has been removed. So it means it again becomes slender. And this is the typical section in which you can see we have one story basement and we have 18th floor, which will become a 20-story building, and the typical height is 12 feet. Normally, in the high-rise building, the height is 12 feet because if you remove the beam depth and false ceiling, so the client will get 10 feet clear height, which is sufficient for the survival. So the first method, now we will go to the first method and we will see what what does it say the first method, and we will again come to the AutoCAD. The first method is to direct import of the grid lines and columns from the CAD file, and it says the grid lines in the draw grid lines in CAD file or columns at the desired locations, and obviously the architect will locate those columns. If there is no columns and grid lines, then you are supposed to provide grid lines and columns uh, at each interval, and then you have to send that grids and columns to the architect, and he will approve that. And this is the process of the designing. You have to give proper layer name to the grid and columns. Please try to join the class one time. So the second step is to give proper layer name to the grid and columns, and then you have to save it as DXF file and remove the remaining items, right? And then you have to import this DXF file to the ETAB, which we will do, but let us perform these first three steps. The first step is already done, that we have columns and grid lines, right? That we have columns and we have grid lines. The second step is to give proper name. If you right click on it, so you can see that the layer is column, and the column should be a rectangle, not a single lines or a block. So it should be a proper polygon or a rectangle, and you should give a proper name to the grids, which have given a G to these grid lines. So, and if you want to draw the walls, but I will give you this tip, that do not draw these walls on the direct importation, because there will be connectivity issue in the walls. So better to draw only columns and grids in the direct importation from the CAD file to the ETAB, and you can easily draw these walls when you have grid lines in ETAB. You will see that. So we have these stairs and these stairs. So what you have to do, you have to select this plan and you have to control C and open a new file, AutoCAD, new template, and control V, place it, move these extra dimensions, place this near the origin, right? And make sure that it has proper layers and rectangle. Now this has been done. The next step is to save it as DXF file, save as, right? And save this DXF file and name it, for example, basement plan. and close it, because when you do not close this file, so it will not be imported into the ETAB. So let me close this. It will again ask to save this format in the Excel file again. Okay, yes. Displacement plan, yes. So this file has been closed. Now open the ETAB. So, so this is the interface of the ETAB. So when you click on this new model, so this tab will appear, and keep this as default because you want to design it ACA 31819. So if you want to change it, you can change and select your design code. So let me keep it as default settings. Click on OK. As we are importing directly from the AutoCAD, so I will click on the blank and click on the number of story as 20. And there is no use when you are clicking on the blank. Click and click OK. Right. So when you right click on the add modify grids, you can see these stories grid stories data has been imported without any grids, and the story height is 12. You can change it. For example, if the story height is different for story 5, so you can change it manually in here. Right, so click OK. Now go to the plane view of the story 1, which will be the basement slab, and go to the file, click on the import, and click on the DXF architecture plan, and click on the basement plan which we have saved. And from here, keep everything as default, and on this tab, CAD drawing units, it is in inches. It was also in that in inches. And click on the story 1 because you have opened the plan view of story 1. So if you have opened the story 2 and you select story 1, so it will not be imported, right? So this is important. So story 1 is in plan view of story 1. Select story 1, click OK. So this plan has been imported to the ETAB. So now you can draw the columns one by one. For example, if I click on this quick draw columns and select, for example, a property of C30 cross 30, if I go over here, there's a point. So if I click on this, so this column has been modeled, right? Just like this, just like that, for example, right? So there's a quick way to draw all of these columns and with the same size that you have drawn in the AutoCAD. For example, you have drawn the size, let me check that. The size of the column in the CAD file was 42 inches cross 42 inches, the internal, and the external was 36, which is 3 feet 36 inches cross 36 inches. So if you want to model the same size of columns in the ETAB, then you have to define that column and draw that model that column one by one. So the easiest way is to go to the Modeler Explorer, click on the Display tab. For example, this is Model, this is Display. Uh, Click on the Plane Views, click on the Architecture Layers, and here is the layer of the column. So you right click on the column and click Add Column Object, so it will draw all of the columns in one click. Right, you can see that. Let me go to the 3D. So you can see that all of the column has been drawn in one click of the same size that you have imported from the CAD file. Similarly, you can convert the grid lines of the AutoCAD to the grid lines of the ETAB by similarly same layer. For example, the layer for the grid was G. Right click on this layer and click on Add Grid. So the grid lines of the AutoCAD has been converted into the grid lines of the ETAB. How do you verify this? By right clicking, add modifier grids, click on the show modifier grid system, and you can see that the general grids, this is the grids that has been converted from the AutoCAD to the ETAB. You can we can also see that by clicking on the options, architecture plan options, deselect all. Now this grid is the ETAB grid. The first one was the AutoCAD, and now this is the ETAB. The the benefit of converting benefit of converting this grid lines is that makes your work easy, right? You will see that, for example, uh, let me click on this. If you do not have any grid lines, then you want to draw a beam, then you will be clicking manually. Let me uncheck the architecture layers. You have to draw it manually, and it has been manually one by one, right? So the simple way, quickest way is to convert the grids and click on the quick beams, select the desired selection section, for example 15 cross 24, and drag a window just like that, and you will draw the beams in one click as per the grid lines you have defined in the ETAB. But the grid lines must be passing specifically from the center of the column in the ETAB, right? From the in it will be verified in the AutoCAD that the grid line must be passing to the center of the column. Similarly, you can draw, for example, let me move in the upper story. You can draw the columns by just one clicking on the grids, and you can draw the beams just like that. So this is the easiest way. You can also draw the slabs, quick draw floors, and select the desired section, and the slab has been drawn, right? So this has been drawn in few minutes. You can also draw walls very quickly using these grid lines by clicking on this quick draw walls. Select your wall property, for example, shear wall 9 inch, and click on this grid and click on this grid, right? Similarly on this grid and on this grid. So this is how you will take the advantage of the grid lines. So let me undo this walls, and we will go towards the modeling. So this is the first method that you import directly from the AutoCAD, and which is very easy. So the fourth part was to import this TXF file in ETAB in the same story in which currently open, which I have explained, and save this file and start modeling in the tab using architecture drawings. Let me open another file. The second method is using a quick draw template of the ETAB. You have to insert the data of the building in different tabs like number of stories, number of grids lines, story height, grid spacing, and then you have to select the slab system, beam slab system, flap slab system, and then you have to then select the section properties of the columns, beams, and slab. Enter load data, edit grid spacing, click OK, the proposed building will appear, and then you can save that file and you can work further on it. So click on the new model, click Click OK. So this is the quick template. You can see new model quick templates. Here you will define the grid spacing. For example, in X you have 25, in Y you have 20. Sorry, we have in X we have 8 grids, and in Y we have 10. And in the X direction we have 25, and in the Y we have 20 feet. You can verify that. And the number of story is 20, and the height of the story is 12 feet. You want to draw only grid lines, so click on the grid only. If you want to model with the structural sections, so click on the two-way or rip slab. Uncheck the rip slab. What will be the depth of the beams in the x direction, which is 24, which will be the width is 15, for example. And the dead load is addition, which is SDL. For example, you will add 50, and the live load is 40. Fix it at the bottom, which is the restraint. And the flow diaphragm rigidity you want to add is rigid, semi-rigid, or no diaphragm. We click it as rigid. Slab thickness you must, for example, take 7 inches, and the column size is a square, for example, 36 inches. Click OK and click OK. It will take a few seconds, and it will appear like this. So let me check the floors and beams and click on the 3D. You can see that the whole model has been built with few minutes. So this is actually practically possible or easy for a regular building, that we have a regular building, regular grids, and you can use the script templates. But you have irregular building, L shape and other V shape, so you can use that importation from the CAD file to the ETAB. The next one is the third method, which is actually you do not want to model a complete building with your beams, column, slab section. You want to only import the grid lines. For example, 8 in this direction, 10 in this. It is 25. You want to edit these grid lines, and you want to draw the beams and columns manually. So you can do that. Select only grids and click OK. So now the grids has been defined. Now you are at the same stage where you have converted the CAD grid into the ETAB. Now you can draw your beams, right, as we have drawn in the first method. This has been unchecked, so check that. And you can draw the quick columns like that. And you can, for example, this is 20 story. Quick draw, for example, floors, and this is 6.5, and it has been modeled in the 20th floor. Select all of these, go to the edit, replicate, click on the story, select story 19 up to the story 1, and click OK. So the whole story will be replicated to the bottom. So this is another method. You can also edit the grid, right? You can also edit the grid spacing. For example, this is not 25, this is 15, this is 30, this is 45, and you can click OK. You can edit your grid system like that. So we'll be focusing on the first method, and we will be modeling your actual architecture. So this was our model from the method 1, and we will go to the story data, and we will name it properly. For example, this is raft, this is basement, right? This is first, this is ground, this is first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12, 13, 14, 15, 16, 17, and click. We will go to the basement plan, and we will open the architecture drawing which we have deselected that. So you can see that we have a ramp over here which is coming from the ground floor to the raft, which is the basement, and we have stairs in this grid, and we have lift in this. Let me for example delete this story. So we will delete this slab from the lift, and from this, from this, and from this. We will also delete this. This will be the opening for the ramp, and we will delete that as well. Now we will draw our retaining wall by using quick draw walls, and it will be, for example, we will discuss the sizes in the module 3. So let us model it as at any size. I will take a window like this. So this is the advantage of the grid system, that you can easily quickly draw your structural members. The next is to draw these shear walls. Uh, Click on this grid, and now we will model the lift walls, and we will check the sizes of the lift walls from the architecture. That we have 8 feet in this direction, and we have 10 feet in this direction. We have 2 cores in this wall, and we have 2 cores in this wall. Now we will go to the draw wall stacks. Click on this. So there are varieties of shear walls and lift walls you can model. Only single shear wall you can model with 1 core, 2 core. You can also change it with 3 core. For example, this is 3. So click on this, so you will get 3 core. For example, this is 4. You will get 4 cores of lift walls. So now we have 2 cores. So I will add 2 cores. So the length parallel to the door, it was 10 feet, and the other was 8 feet. The openings is normally 4 feet, and the height we will take is 7 feet. The wall thickness initially we will take is 18 inches, because it is a 20-story building, and we are using these walls as a structure, special structure walls for in our dual system. Now click OK. So now you have to click the location of for the lifts. So now you can zoom it, and you can see the shape of the wall is same as I have mentioned uh, in the CAD file. So let us, it is not in same size. This is 10 feet. This is 8 feet and this is 10 feet. Now it is equal. So in reality, the lift walls has connection with the columns at the edge, but in the tab you must connect the joints. So we have to connect the end joint of the lift wall to the uh, column. We are clicking on this. So this has been drawn, and we have to rotate it by 180 degree, minus 180 degree. So it doors will be in the same direction as per the architecture, and we will click on this. The lift wall has been drawn to the top because we have selected all stories. If you want to duplicate it same as we did the columns, so you can delete that. And let me do that. Going to the set building view limits, show only ground, and let me delete this and click on the show all. Only in one story we have drawn the lift. Right. So next step is to draw the ramp. We will go to the hide these grids and click on this draw floors, not the quick one, and click on the, for example, ramp 12. Click on this joint and click on this joint, and this joint. So this is the ramp. Let me off the architecture. Draw the beams for the support of the ramp. Same points parallel to the ramp. Now select the columns that are intersecting with these beams and go to the edit frame, divide frames and break into the with selected frames and joints. And you can see that has been divided. Select this, click on this point, on this point, click on this point and this click this no joint. Now the joint has been created. So if you click on the exterior view, you can see that the beam has been drawn for the support of the ramp. Now the lift, the area where we have deleted the slab, we will draw it manually. Click on this joint, on this. So this is how it is done. Now we will come to the stairs later on if we have time. So this is basement plan. Let me save that. Now go to the architecture. This has been modeled. Now the next step is to model the ground floor to fifth floor, in which we have removed one grid from around the building. This grid 10, 1, A and H has been removed, means these columns are only for the one story. So we will select all, and we will go to the edit, replicate, and stories that will be ground floor. Now we do not have any retaining wall in the ground floor, so we will delete this retaining wall first, and now we will delete this grid, this one, and this one. So this will be your ground floor, and it has been replicated from the ground floor to the fifth floor. So we will select this ground floor, and we will go to the replicate, and it will go to the from first to fifth floor. Now we will go to the fifth floor, and from the fifth we have sixth floor, in which we have the same grids, but we have opening in here. uh, at the mid we have no slab, so in the sixth floor we will have opening, and that opening will be up to the 10th floor, because the restaurants and the apartments will have different loadings, but the architecture and grids are the same. So we will go to the key tab, and we will select this fifth floor, and we will replicate it to the sixth floor, and we will create an opening. For example, these two are the opening in the architecture drawings, and this has been shifted, replicated from the 7th to 10th floor. Now again we will go to the 10th floor, where we will change the architecture. From 7 to 10 it has the same opening, but from the 11 to 18th one grid has been removed, which is the grid 2. It has been replicated to the 18th floor. So we will select this 10th floor, edit, replicate, put is story, uh, click on the 11, remove this grid, now replicate to the 18th floor, 12 to 18, click OK. Now click on the 3D, you can see that, let me check this, model has been created for the proposed building. Click on the extrude view, you can see that this is the model for the proposed 20-story building. Now we will go to the 18th floor, and we will model the overhead water tank and home P, which is the roof. Right click on the modify grids, click on the quick add stories, add quick stories, modify it, name it is overhead water tank bottom, and name it is Momty or overhead water tank top. So that will be 3 feet and that will be 6 feet. Go to the 18th floor, select these and select this, and the water tanks was actually on this plane because we have opening in here. So we will have to replicate these and click on edit, replicate, replicate into Momty and water tank bottom. Okay. Now remove the beams from the overhead water tank bottom for the Momties and this slab as well. And keep these beams in the water tank bottom. We'll go to up the floor, remove this, add slab to this Momty, which is the Momty level, and same is in here, and remove that. Remove these columns because we will draw walls for the overhead water tank. Click on the draw walls and draw these walls for the overhead water tank. Save it. Go to 3D and you can see that the Momty and water tanks has been modeled. Let us go to the render view. Click on the option, keyboard view, and the rendered view will be F2 and click on F2. Now you can see this is the rendered view of your proposed building. This is the Momty and this is the overhead water tank. This is the terrace and the last one is the basement. This is the ramp. Stairs, actually modeling of the stairs takes a lot of time and have no significant effect or contribution in the overall performance of the structure. It may contribute in the seismic weight of the structure, but that amount of weight can be neglected, but you can add the weight of the structure of the stairs. Sometimes stairs do not have any beam column support as it is built in 4.5 inches thick walls. Therefore, designers do not model stairs, although if someone wants to model it, he or she can model it. For the partition walls, the unconfined brick masonry or concrete masonry walls cannot be designed in ETABS as frames are designed as with elastic analysis and bricks will go under inelastic range during the design earthquake. So the if someone wants to model the partition walls, it can be modeled in ETAB using the struts following FEMA 356 procedure, but is a very lengthy process and normally adopted during structural assessment of the existing buildings. Therefore, load of these partition walls are taken in the design process. So this was the whole story about the modeling. So I have skipped many things because it is not a basic course. So I hope you know these things which I have done in the model. Now, if you have any question, you can ask. Gigi? Yes, I'm listening.